Let us continue our discussion of Earth's history. How did things evolve? We said there was no oxygen in the air before. Who started producing oxygen? So, wasn't there any oxygen on Earth at all? Yes, there was oxygen, but it was trapped in the water and stone. The oceans that filled up would have had what is called dissolved oxygen. The fish that live in the water need to breathe, so they take in the water and pull out the water and they extract oxygen through the gills. You've learned it somewhere already in school, right? So you see, oxygen is pretty pushy stuff. It wants to connect with everything and oxidize many things, and when it connects with hydrogen it forms water. Together with iron and water it creates rust that you are so used to, and combined with methane it makes water and CO2, carbon dioxide. So luckily at a certain point bacteria developed that turn CO2 into oxygen. You already know that's called photosynthesis. So this process is known as photosynthesis. Together with sunlight and water, the bacteria broke the CO2 into pieces, creating carbon and oxygen. The bacteria built their tiny little bodies out of carbon, and the oxygen of course immediately went off to make more connections with iron and other metals. But after a while the metals had enough. There was no room for more oxygen. The only place the oxygen to go was then into the air. If the water gets saturated with oxygen, dissolved oxygen cannot get dissolved anymore, then oxygen molecules to begin to escape, because all these reactions are happening high up in the air. The oxygen formed an important protective layer once you started filling up the atmosphere with oxygen, right? Oxygen is going to rise and take every place in the atmosphere, and it's going to reach the upper atmosphere. Some of you may know that the lower atmosphere is called the troposphere, which I have discussed in the previous sections from other books, and the layer above it called the stratosphere. In the stratosphere you may know that the temperature begins to increase, because in the troposphere, from the surface, which is warm, as you go up it gets colder. So even if you're in a cold place, if you go up in the atmosphere it will only get colder. But this oxygen in the stratosphere was split into oxygen atoms. Oxygen O2 is a molecule, and this high energy coming from the sun split the oxygen into atoms, and one atom of oxygen combined with one molecule of oxygen to form ozone, which is formula is O3. If you don't know chemistry, don't worry about it, but you may have heard of ozone, the ozone layer and so on. And in the troposphere, ozone is a bad thing. If you breathe ozone, it's toxic, it'll hurt your lungs and it'll make you sick. Okay, so together with sunlight and water, bacteria broke the CO2, and then we started filling the oxygen into the atmosphere, into the air, high up in the air. Oxygen formed an important protective layer against sun's ultraviolet rays, UV as we call them. That's the ozone layer. UV can burn your skin, hurt your DNA, and not only us, all species including plants and crops and vegetation and so on. But oxygen wouldn't be oxygen if it didn't start getting involved with other substances as well, right? And this time it got down to work with methane. There was plenty of methane in the atmosphere. When oxygen encounters methane, it turns it into CO2 and water. As a greenhouse gas, that's annoying, but it's not as bad as methane. What does it mean? First of all, when you oxidize things, when you have too much oxygen, oxygen begins to oxidize everything. And we didn't say exactly where the methane came from, so we don't always know the answers, but maybe some form of methanogenesis, or like photosynthesis. You can have bacteria that are producing methane, or it could be coming from the volcanoes and this hot melting lava and magma and so on and so forth. Nonetheless, lots of methane was there, and as oxygen began to increase, it began to oxidize methane, and you can write the equations if you know enough chemistry, that CH4 plus O2 with some numbers goes into CO2 plus H2O and so on and so forth. So oxygen made CO2 out of methane, and the bacteria made oxygen out of CO2. This gradually made the atmosphere less greenhousey, which means it wasn't trapping as much of the thermal energy going out of the Earth's atmosphere as we saw here. So this layer became less effective in trapping the energy that was going out. Your body emits thermal energy as well, as we said before, right? So why is methane more powerful as a greenhouse gas than oxygen? Well, these greenhouse gases like CO2 and methane and N2O and water vapor, they allow sunlight to come in, but when the thermal energy is trying to go out, they can absorb them like a blanket. And which blanket is more powerful, more effective in trapping the heat, more effective in making warmer, depends on the gas. So CO2 is generally the standard. Methane is about 25 times as powerful a blanket as CO2. Okay, so just remember that. So here are some bacteria that are taking in CO2 and producing oxygen and keeping the carbon and producing carbohydrates and sugar, which they need for energy. And this is what we do. We eat food, we breathe oxygen and produce CO2, whereas photosynthesizers breathe CO2, produce sugar and emit oxygen. They also burn the sugar and produce CO2 as well, right? Plants are doing photosynthesis during the day when there is sunlight because they need the sun, but at night they are breathing just like us, and during the day also they are breathing, but at night they only produce CO2 and so on. Okay, so these, if you know more chemistry or biology, these are called autotrophs, which means they produce their own energy, and they have things like chlorophyll or plastids, which is why they are looking green, and not all of them cannot move. This one is shown with some cilia and a tail which can make it move, but these are also referred to as plankton, Plankton, which you may have heard of. Plankters, this comes from a Greek word called planktos. I don't know how it's pronounced in Greek, but you can tell me. And planktos means it's a drifter, it cannot really swim, but over time some of them evolved to have some tail to change direction, to go up and down and so on and so forth. Okay, so maybe we will come back and talk about the snowball effect in the next podcast. This is only about 8.5 minutes, but that's okay. You get the idea now that sun formed, the earth formed, everything was hot still, and lava and the plates had not formed, and methane was a lot, and then things began to cool down, and oxygen was evolving in the ocean and dissolved, and then it got too much and it started coming out, and we had formed rocks by cooling down the lava, and plates were beginning to form. Ocean crust still keeps forming, and the land crust. If you know the earth structure, you already know that it has an inner core and the outer core and the mantle, and the crust and the mantle is made up of it's got an asthenosphere and hard rock like structure and so on and so forth. So we only want to focus on climate and climate change, but geology is a very integral part of climate, because when you move plates and build mountains affect how the winds go, and if the winds are trying to climb the mountain, then you may know that they expand as they rise because the pressure decreases in the atmosphere as you go from the surface to the upper atmosphere. If pressure decreases, it's like a balloon that will expand, and then if it expands, you may know enough chemistry that it will cool, and if it cools, then the water vapor inside gets condensed and it can fall as rain or snow and so on and so forth. So geology and climate act together, and biology and geology and climate also act together, because plants take up CO2 and can cool the climate, which is what we will look at in the next podcast about snowball Earth and how we cooled enough to actually cover almost the entire planet with ice and snow. Right? So when you increase CO2 and methane, you are trapping energy and melting everything. But if you take out CO2 and methane, then you're cooling everything and you can begin to create snow and ice. Right? This is what we'll discuss in the next podcast. Still going with the Earth's history, right? So see you.